Welcome to the 17th tutorial in the GPSX tutorial series, Java Classes in GPSX. While the addition of Python to GPSX allows you to use any open source Python library you would like in GPSX, there may not always be a library available for your current needs. As such, the ability to add Java jar class files has been added to GPSX to give you easy access to jar files. In this tutorial, we will be using the jar files from JFreeChart, an open source Java framework that is used for creating interactive charts. These files will be used to visualize the difference between a steady and non-steady state simulation in GPSX. The goal of this tutorial is to show users how Java jar files can be accessed and used in GPSX simulations using Python. The jar files needed for this tutorial have already been included in the class path, but we will begin by going through the process required to add new jar files to the class path. Begin by opening a new blank GPSX layout. Open the Preferences menu by going to View, Preferences, and navigate to the Python tab. In this tab, there is a field titled Jar Class Path, which will display any jars that have been added to GPSX. New jar files or folders are added in the Jar Class Path Manager, which can be accessed by pressing the Edit button next to the Jar Class Path field. To add the jar file or folder of jars, press the Add Jar Folder button. Pressing this button will open a file directory. In the directory that opens, navigate to the jar or folder of jars that you would like to add to the class path and press the Add Jar Folder button. After adding jars in this field, you will be prompted to restart GPSX to add them to your class path. We will now look at how jars can be used in GPSX. Begin by opening the layout created in Tutorial 1 and save it with an appropriate name. Switch to modeling mode if not already selected. Right-click on the Influent object and select Flow Data. Change the flow type to sinusoidal. Change the influent flow to 3,000 meters cubed per day. Save the layout. Switch to simulation mode. A Python script has been included in the GPSX installation for use in this part of the tutorial. To access it, navigate to the GPSX installation on your machine and select Layouts, Tutorials. Open the script titled Tutorial 17. Save the Python script in the current working directory. Open the Python Script Manager by going to Tools, Python Script Manager. Press the Add button in the Python Script Manager. Select the Tutorial 17 script from the directory and press Open to add the script to the layout. Press the Edit button to open the script in Notepad. Notice that the script is split into two distinct sections, Functions and Plotting. The Functions section contains the default start, cint, and EOR functions as well as a new function called createDialPlot. In the cint function, the values of time and TSS in the recycle stream are being collected at every communication interval and stored in a variable. The createDialPlot function defines the creation of a dial plot in the Java virtual machine to display the time elapsed in the simulation. The plotting section of the script creates a JPanel that will contain both the dial plot and an XY series plot on it. It is important to note that there are two additional GPSX recognized Python commands added to this part of the script. GPSX reset all values is a command that resets all of the values currently in the layout to the value they were defined to be when the model was built. No inputs are required in this command. The second command is the GPSX set steady command. This command allows you to set the value of the steady state variable in GPSX. This command requires you to enter a Boolean value in the parentheses. Note that steady state is currently turned off. Save the script. Press the Run Script button in the Python Script Manager. By viewing the output plot, it can be seen that the total suspended solids in the recycle stream are initially very high and erratic. As the simulation proceeds, the total suspended solids concentration begins to stabilize and reflect the expected sinusoidal pattern. This represents the system reaching steady state. We will now make some changes to the Python script. Press Edit in the Python Script Manager. Change the Boolean value in the GPSX setSteady command to true. Additionally, locate the range axes setRange command and set the upper limit of the chart to 8,000 mg of TSS per liter. Save the Python script. Press the Run Script button in the Python Script Manager. Notice in the output plot that the total suspended solids concentration in the recycle stream is immediately stable and presents the expected sinusoidal pattern. It is important to note that the non-steady state simulation converges to the same output pattern that is presented in the steady state plot. You have now completed the 17th tutorial in the GPSX tutorial series. You should now be familiar with adding Java jar files to the class path used by GPSX and adding Java code to your Python scripts.